Okay, this is Mr. Scott, and I'm sitting at home on a snowy, our second snow day with my wife and the dogs and grandbaby, and so this may not be perfect, but I'm going to try and get it done in one take. So there'll be some flaws probably, but you're going to have to deal with it. Anyway, today we're going to talk about climate change. There's a lot of confusion about climate change and global warming, and I'm going to try and clear that up for you and give you a little lesson, some background. We're going to watch a short video. You're going to follow along. You're going to think about the video, and then you're going to answer some questions. By the time we get done, hopefully you will know more about climate change and global warming than most adults, and quite possibly more than our president. If you look at his latest tweet, I have it posted here. It says, in the beautiful Midwest, wind chill temperatures are reaching minus 60 degrees, the coldest ever recorded. In coming days, expected to get even colder. People can't last outside even for minutes. What the blank is going on with this global warming? Please come back fast. We need you. If you look at this tweet, there's 210,000 people that liked this video, because you can see that it says 210K next to the heart. That means 210,000. K means kilo, which is Latin for 1,000. The president, his latest tweet has more than 210,000 likes, and he is feeling the heat from his critics for being ignorant, uninformed, and even dangerous. And I'll explain why. Here's the science behind it. From the science community, scientific evidence paints a clear picture. Climate change is happening. It is caused in large part by the human activity, and it will have many serious and potential damaging effects in the decades ahead, and could be irreversible. Greenhouse gas emissions from cars, power plants, and other man-made sources, rather than natural variations in climate, are the primary causes. These emissions include carbon dioxide, the main greenhouse gas, which has reached a concentration level in our atmosphere that Earth hasn't seen for more than 400,000 years, plus an increase in water vapor caused by higher and higher average surface temperatures, which cause grave concerns about our welfare. These greenhouse gases affect or act like a blanket, trapping the sun's warmth near the Earth's surface and affecting the planet's climate system and increasing convection. And we'll talk a little bit more about what convection is in a later slide. Let's go over some important vocabulary. The Earth's atmosphere. The atmosphere is an extremely thin layer of air extending from the surface of Earth to the edge of space, about 10,000 kilometers or 6,214 miles. Now that's relatively a short distance relative to space. Important vocabulary. Greenhouse gas emissions. These are special gases that are emitted or released in our atmosphere that can absorb thermal energy. Now it's really important to understand that they are gases that absorb thermal energy, because most of the gases in our atmosphere do not absorb energy. It allows it to pass right through. But these greenhouse gases are water vapor, which is one of the major ones, CO2 gases, methane gas, and nitrous oxide. And I'll talk about their causes of those later. Carbon dioxide. Let's talk about carbon dioxide. We've talked a lot about carbon dioxide in class. Carbon dioxide is a greenhouse gas that is released into our atmosphere that absorbs thermal energy and causes global warming and climate change. The major cause of this is man-made through the burning of fossil fuels. Those fossil fuels are coal, natural gas, and oil or petroleum products. Weather. Weather is defined as the state of the atmosphere with respect to wind, temperature, cloudiness, moisture, pressure, convection, and other weather-related anomalies like storms, funnel clouds, other thunderstorms, hurricanes, and that kind of thing. Climate. Climate is the statistics of weather over a long period of time. It is measured by assessing the pattern of variations in temperature, humidity, atmospheric pressure, wind, precipitation, or rain, like right, atmospheric particle count, and other meteorological varieties in a given region over a long period of time. In other words, it's the weather over a long period of time in a certain area. When we talk about global climate, we're talking about the average in all locations. Let's talk about the atmospheric composition, or what our atmosphere is made of. The composition of air that surrounds Earth is 78% nitrogen, 21% oxygen, 0.93% argon, and 0.04% carbon dioxide. And then there's traces of neon, helium, methane, krypton, hydrogen, as well as water vapor. So water vapor is a real small amount, and you know how many clouds there are in space. So the water vapor is very close to Earth's surface, and it really causes a lot of temperature change. We know this because on a cloudy day, when the atmosphere is cloudy, close to the Earth's surface, it maintains a higher temperature on the surface of Earth. But on a clear night, we know that it gets really, really cold. Evidence of that is sitting in a desert. In the middle of the day, it can be 120 degrees, but in the nighttime, it can drop down to below zero because the temperature escapes through the Earth's atmosphere. But with the clouds in the sky, it can be a lot hotter. Major man-made greenhouse gases and their causes. First of all, the biggest one is carbon dioxide, and that's produced from fossil fuels in their combustion, and deforestation, or the burning of forests, or cement production in industrialized countries. The second one is methane, which is fossil fuel production. When we are making fossil fuels, we produce a lot of methane. And then there's agricultural and landfills. Agricultural comes from animals and the methane that they emit. And then nitrous oxide, that's produced when we produce fertilizers of all kinds, fossil fuels, and biomass combustion. So biomass is stuff that we grow and then we burn and use for energy, and some industrial processes. And if you look at these numbers, it's clear to see that there's a huge change from pre-industrial concentrations, these numbers right here, and today's post-industrial concentrations. If you look at the pre-industrial concentration of carbon dioxide, it's 278,000 parts per million in pre-industrial concentrations. Today, they're 390,000. Well, this was in 2011. It's probably higher now. Okay, so, and those are parts per billion. So 278 to 390, a huge increase. That's more than like a third, right? Anyway, huge increases. If we look at methane, look at the production of methane. 722,000 particles per billion. Today, 1,800. More than twice, or more than, almost 3 times. Nitrous oxide is the same thing, about a 30% increase. So the Industrial Revolution has caused a huge amount of increase in fossil fuels. And there are secondary man-made greenhouse gases that are made from refrigerants, electrical transmission, the transmission of electrical energy across wires, and the manufacturing of semiconductors, but negligible compared to the burning of fossil fuels and the other greenhouse gases we talked about. Okay, Greenhouse gases and their effects. What's the big deal about greenhouse gases? Well, you know that heat rises. Everyone has seen steam coming off of a hot cup of coffee or hot chocolate. For thousands of years, the majority of heat from the Earth's surface has escaped into space. Since the Industrial Revolution, the time that we started manufacturing things with big production plants and using fossil fuels to power them, humans have been dumping CO2, billions of tons, into the atmosphere, the layer of gases that surround Earth. And we talked about the atmosphere. And those gases are absorbing more and more heat that previously escaped into space. So CO2 absorbs more thermal heat energy than nitrogen, oxygen, and ozone, which makes up the majority of our atmosphere. CO2 absorbs radiant energy, which is different than those other gases. CO2 is actually dense enough that when thermal waves go through it, it traps them, it stops them. It absorbs that energy and they get warm. And that creates like a thermal blanket over Earth with those gases. Over time, this buildup of CO2 becomes thicker and thicker and absorbs more and more heat, making our overall temperature on Earth warmer. It also increases convection. We'll talk about that in a little bit. Greenhouse gases act like a blanket. Here's a a picture, and I've added some molecules, the little dots, to the picture of water vapor, CO2 molecules, and methane molecules, and I'll explain them in a second. Anyway, so sunlight, the way that this works is that sunlight passes through our atmosphere and strikes Earth. Now, it's critical to understand that these heat waves, or the light waves coming from the sun, are at a wavelength that aren't absorbed by all of the gases in our atmosphere on the way into Earth, because they're not thermal waves. That radiant energy, the sun's energy waves, hits Earth's surface both in the water and land, because most of our Earth's surface is water, but when it hits land, it warms the land as well. The surface gets warmer and the heat rises in the form of steam from the water and thermal energy, or heat, just like the cup of hot cocoa. Some of the energy comes off of the cup, some of the energy comes from the liquid that's inside. You can see that on a cold day when you see the water vapor coming off of a hot cup of coffee or cocoa. The heat is absorbed in the atmosphere by the CO2 gases and the other greenhouse gases like water vapor and methane, and it makes them warmer. So if you look at this picture, you can see the sun's rays hitting Earth. Now they get converted once they hit Earth and they hit the surface's density is 1,000 times more, if not, like 10,000 times more than the gases that surround it in the atmosphere. Well, that thermal heat, that absorption of that heat, or actually the surface converts it into heat. Now you can feel the difference. So think about this: when you're sitting in a classroom and then you walk outside, it doesn't seem so hot when you're inside the classroom because the light rays aren't hitting you directly. But when you get out into the direct sunlight, you feel that change in temperature. Well, the Earth experiences the same thing. The sun's rays hit Earth, it warms that surface, and then that warmth that's on the surface radiates away from Earth's surface, and it radiates towards the atmosphere. Well, in the last 10,000 years, most of that heat just escapes into outer space, goes right through. However, since the Industrial Revolution and the increase of these greenhouse gases, a lot of those greenhouse gases trap that heat energy, and it actually stores it, and it acts like a blanket around Earth. Now this is what's called the greenhouse effect, and it's because it acts like a greenhouse. A greenhouse acts, it takes the thermal energy through the glass, striking the ground or the objects that are in the greenhouse, warming them. And then when the thermal energy rises off of the surface of the greenhouse, it's trapped by the glass, because the thermal energy can be trapped by the glass, but the light energy isn't trapped by the sun, from the sun when it initially comes through. So anyway, it creates this blanket, this heated blanket that covers Earth's surface. The increase in temperature increases convection, and it increases weather disasters. And we've seen over the last decade the increase in tornadoes, tropical storms, hurricanes, and just rainstorms and droughts, and change in temperature of the water and melting of ice on the polar caps. So this convection and this heat change, it's depicted in this picture. You can see that the heat waves cause this convection, and it makes the warm air spin. And when it spins, it creates these storms. So can you guess what the increase in convection causes on Earth's surface? Like I said, more hurricanes, more tornadoes, more droughts, more tropical storms, and the increase of the ocean's temperatures that melt more and more of the ice cap. So there are arguments against climate change, and these arguments kind of muddy the water in politics today, and people get confused, and I'm going to try and straighten that out in a second. First of all, some scientists were skeptical at first because there was evidence that there was climate change that had happened before on Earth, like our former ice age, and they said it was similar to these time periods, and it really isn't anything that we could do anything about, and it had nothing to do with human behavior. But it was just basically a cycle that happens every 1,000 or 10,000 or a million years on Earth's surface. Well, now the overwhelming majority of scientists agree that climate change is a real thing because of the constant and prevailing temperature increases that have happened over the last 5 decades. This is the time period after the Industrial Revolution started in the 1700s and until the present time. But in the last 5 decades, population increases and the mass production of products in second and third and even fourth world countries has increased the concentration of carbon dioxide gases in our atmosphere. So they've tracked it over the last 5 years, and that there's an alarming increase in CO2 gases and climate change over the last 50 years. The major problem with the whole idea of global warming and climate change is that there is major political and economic problems. First of all, there's massive confusion. Many people are confused by the fossil fuel companies that campaign to discredit the claims of scientists and the preliminary data from earlier studies that the big oil companies are still citing. Now, those early studies were funded by big oil companies, and guess what? If you have a vested interest in oil coming out on top, the scientists may skew their data and may find reasons to support the oil companies rather than refute and talk about the dangers of burning fossil fuels. More confusion. Many people confuse weather with climate. Weather is a forecast and a day-to-day happenings with temperature, convection, and precipitation. Climate is the overall average condition of weather over a long period of time. So somebody might see that it's one particular day as an extremely cold day, and the other one might be extremely hot, and maybe cite on the hot day that there is climate change, and the cold day that there's no such thing as climate change, just like our president's tweet did. But the confusion comes from understanding that there is change over time, and it's an average over a long period of time that we're concerned with. And the average change is what we're concerned with the most, and that the average temperature is increasing, and it causes a lot more convection and more problems with the storms, like I said. Even more confusion. Some scientists and politicians actually gain from confusing the public because they are influenced by big oil corporations who benefit from the billions and if not trillions of dollars made from fossil fuel production. Now these fossil fuel producing companies, they make trillions of dollars selling their products. So they want to hire scientists, they want to hire politicians, and back politicians that support the use of their product because they have billions of dollars at stake. So you have to really be careful about listening to politicians and some scientists and understand who is funding them. Is it a government-funded product company? Is it a nonprofit company? Is it a real a group of scientists, or is it a group of scientists who have been hired by oil companies? More major economic problems. Economic reasons for the problems that we have. First of all, fossil fuels produce more energy per kilo than any other energy source. So they are relatively cheap to produce and consume. So they're cheap. They produce a lot of energy. They're easy to get, and that's a huge problem economically. More economic reasons. Our whole economy and infrastructure is built to be supported by fossil fuels, so it would be expensive to switch to a clean alternative. Most households and businesses have expensive automobiles that run on fossil fuels. It's estimated that 1 to 1.4 billion automobiles are on the roads today in the world. So just think about that. That 1.4 billion automobiles would have to be dismantled and recycled. And we would have to build new cars to replace them. So replacing 1.4 billion automobiles for transportation and delivery and commuting would be a huge, huge expense. Okay, what is the solution? The solution is very difficult. As you can see, there are political and economic reasons why we aren't switching away from fossil fuels fast enough to stop some of the problems that we're having with climate change. And heads of state from all kinds of countries are trying to deal with this issue, but they're competing with one another in this world economy. China is trying to compete with us. Europe is trying to compete with us. Mexico is trying to compete with us. Canada is trying to compete with us. Australia, Germany, all these industrialized nations. So we've got this global economy. People are trying to compete on an economic level, and yet we understand that if we don't do something, we're going to destroy the earth that we live on. But what is the solution? We have to come up with a solution, because if we don't, our whole civilization could collapse and we could all die. Now, is that going to happen in the next 10 years? No. Is it going to happen in the next 100 years? It could. Could it happen in the next 500 years? Yes. Absolutely. So we have to make some kind of concessions, and there has to be a major change, and it has to happen relatively soon. And we have to have all the leaders in the world agree to that. So you can see the problem. But this is what we're going to do. We're going to try and do some research and discover what is the real answer to our energy needs. We started out this whole unit. This unit is called energy for a reason. Energy is the problem. We have to come up with a solution. So you, as a part of the class, are going to do reports on different types of energy, and you're going to argue the pros and cons for your type of energy. And by the time we get done, we'll have some kind of understanding about what the solution is. Then the problem is getting buy-in from the rest of the world, creating the infrastructure, and getting everybody to commit to it and not cheat. And that's a big problem. So what's the solution? You sixth graders will come up with it. And you're going to come up with the answer in this assignment. But first of all, you're going to answer questions about what we just talked about. Thank you. Talk to you later. Bye.